Welcome to EDU World Space.
Alright, so here's the problem 23.38. We're going to write the names for the following coordination compounds. So writing the names are pretty straightforward by looking at the compounds. However, we have to find the oxidation state for the center atom because we're going to write that in Roman number. So for example, the first one, we have CdEnCl2. Alright, so the oxidation state for the ligand En, which is called ethylene diamine, is 0. Chloride, we know, is -1, and there are 2 of them. So if we have cadmium has oxidation equal to X, so X plus 0 plus -1 times 2, and the complex will be neutral, that will be equal to 0. So we have X minus 2 equal to 0. So X equal to positive 2. That will be the oxidation state for cadmium. All right, so now we write the name for this complex. That will be dichloro, since there are 2 chlorides. And the ligand En is called ethylene diamine. Center metal is cadmium. And the oxidation state of cadmium is 2. So that is the name for question A. Now let's look at question B. We have K4MnCN6. Alright, so for this one, we know that potassium is +1 times 4 of them. And the charge of manganese here is X. And the cyanide ligands have a -1 oxidation state times 6. And that will be equal to 0. So -4 plus X minus, +4 plus X minus 6 equal to 0. So we get X equal to also +2. So the name for this complex will be potassium 6 cyanide. So that is hexa. Cyano, center metal is manganite. And the oxidation state is 2. Alright, so part C, we have CrNH3 5 CO3 Cl. Alright, so for this complex, the oxidation state of chromium X, the oxidation state for ammonia group is 0, so 0 times 5. And for CO3, that is a -2, and chloride is -1, and altogether equal to 0. So we have X plus 0 minus 2 minus 1 equal to 0. So we get the number X equal to +3. So chromium has an oxidation state of +3. So the name for this complex would be, starting with the first ligand, pentamine carbonato. CO3 is called the carbonato. And center metal is chromium. Chromium oxidation state is 3. Chloride. All right, so this is the name for question C. Last one, part D, we have IR NH3 4 H2O 2 NO3 3. Alright, so for this complex, we assume that the metal has an oxidation number of X, and the group amino has an oxidation number of 0 times 4. Water also have 0 oxidation number, and then the group of NO3 has -1 times 3 equal to 0. So in this case, X minus 3 equal to 0. The number of X will be equal to +3. So the name for this complex, starting with the amino, it will be tetraamine, and there are 2 water, di-aqua, center atom is iridium, oxidation state is 3, nitrate.